Welcome to Qt Widgets and More. In today's episode and the next episode, we'll be implementing a full-fledged proxy model, including unit tests and all the whistles and bells. The proxy model we're going to implement is a very simple one, namely one that flips the rows. So row 0 becomes row n-1, row 1 becomes n-2, and so on. It doesn't work for trees, but still, it is rather complex to implement it 100% correct. And that's what I'm going to show you here. The problem is that our two usual culprit, that is Qsort filter proxy model and Qidentity proxy model. These are the usual two classes that you can use in many situations, but they don't work here. It's not an identity that only works for those that doesn't change the layout, and it's not sorting or filtering. So, well, we have to roll our entire proxy model of our own. I decided I want to try and do this as right as I possibly can, including all of the signals. And there was actually one of the signals from the underlying model that was so complex that it is dedicated a whole episode next week for that. But in this episode, I'll start out with a simple solution. You can, if with a bit of luck, get that running within 2 or 3 hours, possibly even with unit testing. But if you want to react on the underlying model changing, then you need much more. And that's what we'll see in this video here. And as I said, I'll even add some unit tests so we can see a proper tested proxy model all the way through. Shall we get started with the code? Comes right here. Without the other two, the Qsort filter proxy model and have you ever noticed that I always do like this when I say that name? It's a terrible name. But anyway, without those two, my last resort is to subclass from Qabstract proxy model. I could, of course, have subclassed directly from Qabstract item model and not being a proxy. But then, and sometimes I wonder, did I even win anything from actually subclassing from Qabstract proxy model? But there are definitely situations where you want to subclass from that. Let's look at the API that we need to implement here. I have a bunch of methods that you might never have seen before if you've never done a proper subclass of Qabstract proxy model, and some that you might have seen before. You've definitely seen row count and column count. They still do the same thing, and header data still do the same thing. Then there are two that you might have seen. Well, you will have seen them if you have implemented a tree model, namely index and parent. They do the same as they do in there, namely they create indexes from index or parent, from a given row column parent or from a child. That was what I was about to say. And then there are two other map to source and map from source that are specific to proxy models, and they translate indexes from one domain to the other or the other way around. And there's a virtual method here called setSourceModel. I need to override that so I know whenever a new source model have been set on this proxy so I can connect to all of its signals. Let's have a look at the implementation now. So let's scroll down to something simple. It's always comforting starting to look at row count. And remember, this model here do not handle trees. It could have, but I had no need for it. So really, I thought I was working hard enough just to get this properly working on all tables and list models. Check _row count. That's in previous episode, we had this framework that I created for checking the indexes and other stuff in the proxy model. I'll go and have a look at that. If I have not set the source model, that might actually be that for some reason, another proxy tries to call into me without I having been set up properly enough. Or if the parent is not valid, return 0. Remember, it's always about other proxy models on top of me that could be wrong. Otherwise, the amount of rows that I have is exactly the same amount as my source model have. So I'll just return that here. Column count, exact same story once again. And now up to the index. The index, if you haven't ever implemented a tree model, I can tell you that the only way we can create indexes is using this create index method. And it usually takes row, column, and an internal data pointer of something. But given that I'm a table, there is no internal data. So that's pretty simple. Again, the usual check up here, and then I'll just call create index for row and column. And parent, that is super easy to implement for tables too. You could argue that this should have been the default implementation, but let's not go there. Parent simply returns nothing, because whatever cell you have in the table, the parent is the empty QModel index. Let's scroll down and have a look at map to source and map from source. And you don't use them yourself. Qts, or the tree view or table view or list view or whatever view is not using them, but the implementation for, say, data method, you might have noticed there are no data method in here. So what the data method, its implementation is that it simply call the map to source. So if you want a data for this proxy index, it maps to the source, and then there it called data on the source model with that source index. The implementation, there is some test for validity again here, but if I actually ask for the source index for a valid index, then I'll go and call the source model and ask it for an index for the column that I specified, and then map row for the proxy index here. And the map row method, we can see that right away down here. What it does is relatively simple. You can see here, row 0 become 8 if there are 8 rows in my model. Row 1 becomes 7 to 6, and that's what you see here. Row count -1, so there's 8 rows. So that's 7 minus whatever row. No, there is actually 9 row here, and not just 8 rows. So it is working, and I know that it's working because I've unit tested these things pretty hard. Same thing, map from source. It does exactly the same thing as you will recognize here, but that's not a given that it always does. It's just because of the symmetry of my mapping. Also, header data. It maps it does the map row. So if I'm asking for the horizontal, that's those that goes like this, then it just calls straight onto the source model. But if I'm asking for the verticals, then I need to swap them around, and that's what I do here. I ask my source model for its header data, and then I swap around this section here. And that's about it for the default implementation. Index and parent, super trivial. Row count and column count, similar to other things. Map to and from source, I just need to think a bit hard about how that works. And finally, header data. And my map row, that's also relatively simple. It's just a utility function. So how come there is still a lot of time left in this video? The reason why there is so much more on the video here is that I'm not listening at all to the underlying model. Data changes, it might come in from, say, a socket or some other views that are updating, and I am not listening to that. So my view that sits on top of this proxy model will not update at all. Not a single line of code will be executed whenever it's changing underneath. Or if I add or remove rows, it's even worse, because the data structure above might assume that there is a certain amount of rows, but now there's a different set of rows. And all of that is what we'll be looking at. And I actually made it possible to run the code with a number of different setups. So you might notice there is a version defined in the code that commented out a bunch of lines of code. And let's try running it now to see exactly what happens if I run it without any of those additional signals being listened to. So here is my model. You can see that it has actually been reversed. You didn't see the test data, but it goes like 1, 0, 1, 2, 3. It goes down like this, but you can see that it has been reversed. And you can see the columns here, which would usually be 1, 2, 3, are now 10, 9, 8, and so on. So that's cool. I have a bunch of buttons here just for simulating something happening from the outside of this model. And one of these is update random. And what that does is that it changes some of the cells here. And you can see that if I do stuff here, you can see that it actually changed the 63 here and 27 and so on. It simply adds a bunch of random numbers. And of course, I don't see that because my data structure underneath changes, but there's no information. Well, there is, but I'm not listening to that information from below going up, telling you, hey, you should update your data. Of course, well, I don't listen to it. Let's try and do something much more devastating to here. Let's add a column, see what happens. Of course, the column isn't added in my view here. Maybe if I resize it a bit, it didn't notice that the column was there. It simply did not notice that the column was there. Let's add a bunch of columns and rows and so on. If I try and resort, no, it's just randomly confused now. Let's remove a bunch of columns and see what happens. Kaboom! Now it thought there was, however, 5 columns, but there was only 2 left. So when it went to the underlying model and asked, can you please give me data for this and that? And you can see it's actually in the column, less than column count in my reverse proxy model. That's my check index here that told me, hey, something is not as it should be. You ask for a column that doesn't exist. This is a time where you despair and you say, ooh, that seems to be really difficult. I follow you so far with these 6 method or 7 method that you needed to implement, but you're talking about a lot of signals from underneath. There is data change, there is about to insert rows and about to remove rows and rows inserted and rows removed and lots of methods that you want me to implement. I'd better just forget about proxy models and just get going without them. And you couldn't be more wrong. You are entirely right that there is a lot of work to implement this 100% correct, including unit testing and whatnot. But the lines of code that you saw there, I have that in production. And I know, and there is a comment in my code, I hope, that says this model do not act upon any changes to the signals. I have a model that was a good separation from view and business logic, that extracted and calculated and whatnot, a bunch of different data that was shown in a table. And I didn't change the data of that model as soon as it had been created. So the model would never ever change, which is, I don't know if it's true for you, but for many of my models, they don't change. And if they do change, I will just tear down the view, change the model if it's a larger change, put up a view again, and everything is fine. And I do not need to worry about this. So in that situation, it's perfectly okay to just stop here as long as you comment on that, hey, it doesn't do any changes underneath. But if you want to have something that works more generically, then you need that underneath. And for that, you also better need a bunch of unit tests. Let me show you the code for all of this. Just to scare you off really bad from the beginning, just observe all this code here that we need to get working for this to properly work. But as I said, sometimes you need it all, sometimes you don't need it all. It might be that the structure of the model underneath never changes, but the data does. In that situation, you would be doing just this method here, and all the others you'll be using a trick, namely just connect them to model reset. Let me just scroll down right here and show you that. So version number 3, that's when I will go and look at layout about to be changed and layout changed, and we will see how to implement those. But in version number 2, which is not 1 was the one that just crashed on me, but in version 2, I will not implement these to the fullest extent. What I simply do is that whenever I hear the underlying model telling me I'm about to change the layout, I will tell the view above me, hey, I'm about to reset. And whenever the underlying model says, I have a laid out now, you can go and update proxy models and whatnot, I will proxy Q persistent model indexes. That's what I was about to say. Then I'll just tell the view above, yeah, I am done resetting the model. You can load all your data in again from scratch. That, of course, is a brute force, and trust me, I have in many code reviews in KDAB been told that is, yeah. But again, I'm only human. I only have a finite amount of time, and implementing all of this code here for a model that never ever changes the structure just is a waste of my time. And I always stay by that view. So what I want to do now is that I'll take those changes that are needed, I will implement them properly, and the rest of them, as I said, I will implement them simply by connecting them to the begin and end reset model. Starting out with the data change signal. That signal is emitted every time the data are changed. It's actually the parameter that takes out there are 3 parameters. So the first 2 are indexes. So let me see. It would be like this for me. That means I'll just be like this for you when you are reversed compared to me. So topmost, leftmost, bottommost, rightmost. This range of indexes are changed. That's what the model topmost, leftmost, top, left, bottom, right. That's what I'm trying to say, what they represent. And then there are the roles. So if I had something that was super complex for my views or for me to handle, then they could be not updating all the roles. It's optional if you want to implement these. So what does it look like? Well, I will take my top left and my bottom right, and I'll map these indexes from the source model to me. So I never, ever, sorry if I went into a loop there, give out indexes from any other models than yourself. We saw the check underscore framework earlier on, and there I actually did check throughout every single place that the index was actually mine. So if you use that framework, you should be safe. But I take the index from my source model. So I'm a proxy model asset here. So the source model tells me my index, this and that has changed. I convert them to indexes in mine. But given that it looked like this and that I flip them, now this is not, I should give it this setup here instead. And that's why I calculate the new top left and the new bottom right. And that's the indexes that I have there. The roles didn't change, so it's the same roles. So now I call emit data changed with these 2 indexes and the roles. Next, I will attack not 1, not 2, but 8 signals in the next session here that I'll show you. Namely, the signals indicating a layout change. Not the layout change signal, sorry for the confusion. No, the rows about to be inserted and the rows inserted. Columns about to be inserted and columns inserted. That was 4, and then multiply that with to be and has been removed. Why not just emit signals similar to the data change for these? Well, I can't. That's a problem. These signals are not supposed to be emitted, and Qt has some fancy facility for preventing me doing that. What it wants me is to call these instead, and you'll learn much better next time why that is. It has to do with persistent model indexes. It is super easy presenting this code here. It was super hard getting the head around exactly the off by one errors that I had a bunch of when I wrote this code. So the API for rows about to be inserted signal tells me that a parent here, but I'm a table, so at most, so no trees, so I can ignore that one. The first and the last rows, rather than first and amount, first and last. And as the comment up here says, the indexes start with 0 being before the first element, 1 being between the first and, well, the zeros and the first element, and so on. And then n is actually after the last. So it's there is a n plus 1 possible. Well, if there's eight rows, then there's 9 legal values for this. And that's where I just need to like, yeah, no, minus, no, yeah, right. And that's what we end up here with. So the rows about to be inserted, I need to call upon that begin insert rows mapped to my data structure. Same thing for rows about to be removed. For rows inserted, that one is easy because it doesn't take any parameters. So rows inserted, I just emit int insert rows. Rows removed, int remove rows, and so on. For the column version, it's slightly easier because I don't do any changes of the columns. So they are just matching first, last. And that was 8 signals that was handled there. Super easy. Had I just looked a bit ahead in preparation for this recording here, I could have said not just times 2, but times 3, because we also have the rows about to be moved, rows moved, columns about to be moved, and columns moved, and they look pretty similar and does the same thing with different signals, of course, and a bit of difference in what I need to map. But again, it's the mapping going on here. Finally, we have header data change. The header data change needs to look at the orientation, of course. And if it's just a horizontal, then nothing changes here. If it's vertical, then I need to call the map rows as we saw for the data above. Finally, model about to be reset. That's just begin reset model. Model reset, that's end reset model. But it doesn't need to be like this all the time. It could have been that there was some kind of state in my proxy model, and when I heard these informations about model about to be reset or model reset, that I needed to do much more than what I had in this situation here. And my layout changed. We'll see what all of these is about next time. So until then, well, there's one more thing. The thing that is missing here is, of course, unit testing. This model is relatively complex now, so I should be validating that the code actually works, not just for the model itself, more importantly for the signals being emitted, that it's the right signals being emitted at the right time. So I set out for the mission of writing a good test suite for this particular model. Let me show it to you. I already recorded a video showing you the unit testing framework from Qt. There's a link right here if you are interested in learning more about that. So I'll not go into much details on that. We have a number of slots here, and these are all the test cases. There's a few here that is worthwhile talking about. But let's look at the setup here. I have a number of instance variables down here, simply so that I can reset up a bit known state all the time for each of the test cases. How many rows are there? How many columns are there? I have my input model, that's called model, and I have my reverse rows proxy model, that's called proxy. And then I got 2 spies, and I'll get back to what they do in just a short setup. A short time setup is namely what I'll be talking about now. I start deleting all of these because I'll call setup in each of the functions. My model is just a simple standard item model, and you can see it being set up here. Here is my proxy model. It has the set source model given, which makes a lot of sense. Otherwise, it will be very empty. And here are my 2 spies sets up. So we are ready. And the first test case looks like. Well, that's not even the first test case. You can see up here, it's not a test case because it's in the private section here. It's only those in the slots section. But what does this basic check do? Well, it's just all of them. I had a bunch of basic tests, at least when I wrote it initially, namely comparing that the row count was correct and the column count was correct, and that the data was still correct compared to, well, the flipping that the proxy model was about to do. So I simply created this basic checks, which you'll notice is in a bunch of different methods down here. Basic checks here again, and so on. So here is my first real test case. It's simply test that the row counts are correct, that the column count says the right things, that some of the data is correctly flipped. So again, it's one of those things when you write your unit tests. Be careful that you do not rely too much on knowledge insight like I do up here. It could be totally wrong, but then just by this code being wrong here. So instead, let me just hard code in the expected result for some of them at least, so that I have a pretty good feeling that it's doing the right thing. And now for the rest of them, you notice I'm using table-driven testing. So I have my data set up here. This is for the test of my data change signal. I'm setting up the data structure here. I have 3 tests for hello world and foobar that is inserted at source row, dest row, and column. So at row number 0, column number 0 should be mapped to row 7, and so on. And I fetch my data. I call the setup method, and I insert that text that was given here, the hello, at source row, column. And I now validate that that text is actually both in the model and in the proxy at the position we expect it to. And then I go and look at my model spy. Maybe it's time that I tell you a bit about that. If you had ever been in one of my Qt classes, you might very well have heard me say that our good friend Bjarne Stroustrup forgot one thing when he designed C++. He had public, that's everything from the outside for a class. He had protected, that's the anchoring point for extending that class. And he had private, which was, well, the implementation detail. But as our design patterns book has shown us, there are one thing that we're missing, namely a way for the classes to notify the rest of the world. That would have been awesome had that been built into the language. But it wasn't there, and therefore we have lots of different patterns. Observer pattern, for example, to add that to our view of what is an object. In Qt, we do have that addition, namely signals. So it's super important that the signals are emitted at the right places when you implement objects in Qt, because that's part of the contract now. There is the public, private, and protected, that's the contract, but also when are the signals and with what parameters. And for that, the unit testing framework in Qt has a QSignal spy. The QSignal spy is a mechanism for it to listen to signals of a particular object and then validate that the right signals with the right parameters have been sent out. I extended that slightly to be a class master spy. That does a bit more than just listening to one signal. It namely is able to listen to all of the signals that should or could or ought to or might be, English is such a beautiful language, isn't it, emitted from the models themselves, namely data changed, layout changed, and so on and so on. The gut of the master spy are these 2 methods down here, and it actually boils down to just this one method here, because this is just a special case of the other one. But what it does is that it verifies that this particular signal has been emitted with these parameters here. And this verify multiple emissions is just verifying for a bunch or a list of signals that this particular signal with these parameters has been emitted. Moreover, it also, however, do verify that no more signals has been emitted. So these two methods could be private API, I guess they should have been, and only these two are being used from outside. And what they do, as I said, they verify that a certain set of signals being emitted and nothing else. So I know which exactly it is. So let's go over and look at let's not look at the implementation for the master SPI. You can look at that yourself. Now, let's go over here and look at just the data change signal here. So I simply, I change this text here at this row, this column. So my model should be emitting a data change for that particular index that we have here and to that index there. That's the same index because it's just one cell that has been changed. And my proxy, which I also has a SPI on, should be emitting data changed, and then with these indexes there. And if I go and scroll down a bit, I can see the data change ranged. So I emit on my model something that I would usually not do, but just for the unit test here, it's okay. I emit data changed on my model for a range here. And now I verify that my proxy model actually emits a change in the correct range. Let's also look at rows added. Here I actually verify multiple emissions because there's both the rows about to be inserted and rows inserted, and twice here. So that's about the unit testing framework. I couldn't be bothered explaining it in all the details, and after all, it's not that different. There's lots and lots of test cases down here, and you can actually run them. Let me just show you here, and right-click Run All Tests, and it failed. And where did it fail? Well, it failed on the layout changed, which is good because that's the topic for next week. Almost 15 years ago, at the time, co-worker and good friend of mine, Katrina Niolé, and I performed a song about proxy models in front of a Qt training. It was just for the giggles of it, and it was a lot of fun. She was singing, and let me just, I promised her never ever to put it on YouTube, so sorry about that, but she was singing like, proxy models are really, really great, to which I would interrupt her song and say, they crash. You might know the tunes from elsewhere. Anyway, proxy models are really, really great. And yes, they have a tendency to crash if you are not careful unit testing them. And they are really, really complex if you want it all, as we've seen almost in this episode here. But just remember, a comment can go a long way of telling your coworker, it's okay, I have not gone all the way for all of the signals, listening to them. I will not be able to do that. But hey, you might be getting away with a model reset. Just be careful that if you do model reset on everything and there's a lot of changes, you will be doing an enormous amount of work. But if not, you might have saved yourself several days of coding. And I think if I take into account of unit testing and code review and so on, that we are talking about at least 3-4 days of work to implement what you have been seeing in this and the next episode. Let me also just say one more thing about the implementation that I just remembered that I got spanked for a bit in the code reviews, namely the setting up of all the signals using lambda expressions. That is, it's to me, it's potato. It is certainly a lot of code in one function, but the alternative is also a lot of code. If you look at the link below, there is a link to another proxy model where they set it up using individual methods, and yeah, it's that's also good. I'm a bit undecided. In any case, I hope you have enjoyed this episode, and until next time, have a great time.
Would you like to dive deeper into C++? Then have a look at our highly rated training courses on kdab.com.